Today we're going to talk about subgraphs, so let's define them. We say G prime, which is made up of the vertex set V prime and the edge set E prime, is the subgraph of G, which is made up of the vertex set V and the edge set E, if V prime is a subset of V and E prime is a subset of E. So pretty straightforward. If the vertices in G prime are contained in here and it has the same, if all the edges in here come from this, then we have a subgraph. And then we call a subgraph an induced subgraph if that's true, if the vertices are contained. And also, E prime contains every edge in E between the vertices in V prime. So every possible connection from G is taken down to G prime. Let's see how this works. Okay. First question. Is G prime, given here, a subgraph of G? So let's check. So this is our V, right? And this is our E. This is our V prime, and this is our E prime. So is V prime a subset of V? It is. You can see, so let's say notice or something. Notice that ABC, the vertex set from G prime, is a subset of ABCD. And the edge set, let's make sure that's true. AB shows up in both, BC shows up in both. So the edge set of our new graph is also a subset of the edge set of our original. So G prime is a subgraph of G. Okay, so let's talk about induced subgraphs. So next question, is G prime an induced subgraph? So if we go back to the definition of G prime up here, notice that we do have AB and BC. And so if we think about what induced subgraph should mean, it means that we have all possible edges in our vertex set. So our V prime in this case is BC. And our E prime is ABBC. And so the question is this all possible edges between A, B, and C from G? Right, so using our original graph, G as a definition, right? Does A, B, B, C down here? Let's see. Let's do this. Okay. Does A, B, B, C represent all possible connections between A, B, and C from G? And the answer is no. We are missing. What are we missing? We have AB, we have BC, we don't have AC. We're missing AC from G. So this tells us G prime is not an induced subgraph. And you know, when you're solving problems in graph theory, one good thing to do from the very beginning is draw all these, and maybe we should have done that. But let's draw them all now. So let's think about G. So I'm just going to put the vertices. So here's G. I'm going to put the vertices as a square just because, I don't know, that's how I naturally do this. And we're going to draw G, and then we're going to draw G prime, and then we're going to draw this induced subgraph, which we haven't actually written down. So go back to the definition of G, and let's put in all the edges. So we have A to B, we have A to C, and A to D. We have B to C, and B to D. So here's our original graph G. Our graph G prime, I'm going to put the vertices in the same place, but I'm going to leave D off because D isn't contained in the vertex set of G prime. And then we're going to put in the set of vertices from G, which is just A, B, and BC. And we can see the subgraph in the original graph G. It's the one that goes A, B, B, C. So it's this part without all these other edges. And then let's draw a picture of the induced subgraph on the vertex set ABC. And so again, I'm going to draw the vertices in about the same place, ABC, but this has to have AB, BC, but we also need to have AC. Oops. Sort of a curved one, but that's okay. Okay, and so the induced subgraph, the subgraph between A and BC with all possible edges in the original graph G looks like this.